Welcome students. In this class we will be learning how to solve homogeneous equations. Now imagine you are given this question, say solve x squared negative y squared times dx negative x times y dy is equal to 0. Now foremost, what you have to do is you will have to write this entire equation with dy over dx being featured on the left hand side. So what I would do is first I will try to move this onto the right hand side. So this is going to give me x squared negative y squared times dx is equal to x times y dy. Now since I'm looking for dy over dx, what I wish to do is I would bring this dx down and move this xy to the left hand side. Now when I do that, I get x squared negative y squared divided by xy is equal to dy over dx, and now I can represent dy over dx as x squared negative y squared over xy. Now this step is very critical because it allows us to find if the given equation is homogeneous or not. Now when we talk about homogeneous, the main check should be the degree of the numerator should be the same as the degree of the denominator. Now what is the meaning of this? The meaning is, just go to the numerator and find out what exactly is the degree here. You can see the degree of x squared is 2, degree of y squared is 2. So the total degree of the numerator is 2. And go down to the denominator and find out the degree of the denominator. The degree of the denominator for x is 1 here, the degree of y is 1. So the total degree is going to be 1 plus 1, which is equal to 2. So when the degree of the numerator is same as the degree of the denominator, we can safely conclude that we are dealing with a homogeneous equation. Why is it so important? Because for homogeneous equation, we will make the substitution as y is equal to v times x. Because this substitution will allow us to solve this equation, and this substitution will only be valid and it will give us the required result if it is substituted into a homogeneous equation. So that is why we have to make sure that that check, or in other words this check, holds good. So having mentioned this, let us move on. Now we take y is equal to vx and then we differentiate with respect to x. So when I do that, I get dy over dx is equal to uv formula. V times differentiation of x is 1 positive, x times differentiation of v is dv over dx. So we have got this. Now if I were to take this as 2, I can rewrite 2 as, therefore 2 is rewritten as, in place of dy over dx, I'm going to be substituting v positive x times dv over dx. In place of x squared, I will retain it as it is. In place of y, I will be substituting v times x raised to the power of 2 divided by x times v times x. Now this is equal to x squared negative v squared x squared divided by x squared times v. Now if I were to take an x squared out, this is going to be 1 negative v squared divided by x squared times v. I can clearly cancel out the x squared and x squared, giving me 1 negative v squared divided by v. On the left hand side, I got a v positive x into dv over dx. Now what I wish to do is I would like to move this v to the other side. So if I were to do that, this would give me x times dv over dx is equal to 1 negative v squared divided by v negative v. I can take the LCM for this as v. This will give me 1 negative v squared negative v squared which is going to be 1 negative 2 times v squared divided by v. So what I've got x times dv over dx is equal to 1 negative 2 times v squared over v. Now what we got to do is we will have to use variable separable. So using variable separable, so I'm going to use the short form. We will now have dv, I'm moving this down, 1 negative 2 times v squared, I'm moving this up, so we get a v. I'm moving this to the right, so it's going to be dx. I'm moving x bottom, so I get something like this. So I get a v and 1 negative 2v squared. So first what I will do, this is easily integrable, right? So first what I will do is I will just say consider integral v times dv divided by 1 negative 2 times v squared. So what I would do is I would say let 1 negative 2 times v squared be equal to some t. You differentiate this, you get negative 4 times v dv is equal to dt. So from here you can say v dv is equal to 1 over 4 times dt. Of course you have a negative sign. So if you were to use this substitution, this is going to be negative integral dt. Of course you got a 4 there, I'll write a 4 in this fashion, divided by 1 negative 2v squared is going to be t. This is negative 1 over 4 times ln t, which can be rewritten as negative 1 over 4 times ln of 1 negative 2v squared. This is what I got. So I can place them in modulus. So I have shown you all these things just to make sure that what we would be getting when we integrate. So now I would start off by saying integrating both sides, we get, so what do we get? Integral of this, when we integrate this we get this. So I would place that negative 1 over 4 times ln modulus 1 negative 2 times v squared is equal to ln of x. Of course there is a constant c that is involved. Probably we can place that constant c there. Now what I wish to do is I would like to do some rearrangements. So that is very critical. So I will want to get rid of this 4. So to get rid of this 4 you will have to multiply by 4 throughout. Now if you were to do that, this is going to be negative ln of 1 negative 2v squared. You don't have to place the absolute value, but if you insist you can do that. It's nothing wrong. So this is going to be 4 times ln x positive 4 times c. So this is what you have got. Now if you choose to get rid of this negative sign, then you will have to multiply by negative 4. That would make this as positive, this as negative, and this as negative. Now what you can do is you can move this negative 4 times ln x to this end. So that would mean you get 4 times ln x positive ln of 1 negative 2v squared is equal to negative 4 times c. So this is what you've got. Now you know that there is a formula which states that ln of a positive ln b is equal to ln of a times b. By using this formula I can always rewrite this in this following fashion. However, I can also use this formula. Say you have something like this, 4 times ln a. I can rewrite this as ln of a raised to the power of 4. So this is another formula. So if I were to club these things, this is going to give me ln x to the power of 4 times 1 negative 2 times v squared is equal to negative 4 times c. So this is what I've got. Now what you can do is, if you want to get rid of this logarithm, you can use this formula. You got something like this, ln a to the base e is equal to y. You can write a is equal to e raised to the power of y. So by using this formula, I can always write this as x to the power of 4 times 1 negative v squared is equal to e raised to the power of negative 4 times c. So that's always possible. Now having obtain this, what we have to do is we started with y is equal to v times x. So this would mean my v is equal to y over x. So if I were to take this as 3, therefore I can rewrite 3 as the following. So what I need to do is I need to just make the substitution. V is equal to y over x. So if I do this, this is going to be 1 negative 2 times y over x. It's a square there. It's going to be 2. It's going to be 2 is equal to e raised to the power of negative 4 times c. And you can make the simplification. This is going to be x to the power of 4 times x squared negative 2 times y squared divided by x squared is equal to e raised to the power of negative 4 times c. I can always cancel this x squared against this quantity, thereby giving me x raised to the power of 2 times x squared negative 2 times y squared is equal to e raised to the power of negative 4c. But of course this can be rewritten as a constant, so this would mean I can rewrite this entire quantity as x squared x squared of x squared negative 2 times y squared is equal to a huge c. You can either place a c like this or you can put a c dash. It doesn't matter because it's an arbitrary constant. So this is the required solution, students. We will move on to the next question. Students, we have been given this question: 1 positive e raised to the power of x over y times dx, positive e raised to the power of x over y times 1 negative x over y times dy is equal to 0. We expected to solve this. Well, along the different note, if you haven't subscribed to my channel and if you are interested in upgrading yourself and learning concepts of mathematics and improving your life, I would request you all to stay subscribed, or in other words, subscribe. So having got that out of the way, let's move on. So foremost, what we would like to do is we would like to represent this as dy over dx on the left hand side. So for that, I would like to move this dx onto the other side. So this is going to be e raised to the power of x over y times 1 negative x divided by y times dy is equal to, this is going to be negative of 1 positive e raised to the power of x over y times dx. So if I were to move dx down, this is dy over dx is equal to negative of 1 positive e raised to the power of x over y divided by, I'm moving this down, so this is e raised to the power of x over y times 1 negative x over y. So this is what we have got. Now we will have to check with the degree of the numerator. I see the degree of x is 1 and degree of y is 1. And then coming here to the denominator, the degree is 1 for x, the degree is 1 for y, and it is also 1 and 1. So clearly we can see that the total degree of the numerator versus the denominator remains the same. So we are basically having a homogeneous system which we will have to solve. Now there is a slight change you will have to apply here. Instead of substituting y is equal to vx, we will have to reform this in this fashion. So what I would like to do is, instead of taking it as dy over dx, I would like to have it as dx over dy. So the best way is to rearranging. So this is going to be e raised to the power of x over y times 1 negative x over y divided by 1 positive e raised to the power of x over y, because the quantities are all x over y. Of course there's a negative sign, we can place the negative sign, so this is going to be dx over dy. So now usually we start off with this substitution. We would say y is equal to vx, but we are not going to be using this. Instead of this, we are going to say let x be equal to, so So this is the substitution we would be making. So in this case we would be differentiating with respect to y. So on the left hand side this is going to be dx over dy, and on the right hand side y u into v form. So it's going to be y times, I have to differentiate v, so it's going to be dv over dy positive. Since the differentiation is with reference to y, so we are going to get v. So if I were to take this as 2, so I can state that therefore 2 can be rewritten as, I'll start with this quantity. So in place of dx over dy, I would be substituting v positive y times dv over dy is equal to negative e raised to the power of, so x is equal to y times v, right? So clearly x over y is equal to v, so this is going to be v there and a v here and 1 positive e raised to the power of v. So that is the reason I have made this substitution, x is equal to y times v, because that would prevent us from complicating the substitution process. So what we will have to do is we will have to do some rearrangement and solving. So what I will have to do is I will have to move this v to the other side, and that would give me 1 is equal to negative e raised to the power of v of 1 negative v divided by 1 positive e raised to the power of v. This is going to be negative v. Now simplifying by taking 1 positive e raised to the power of v as the LCM, this is going to be, I'm just using distributive property, e raised to the power of v positive v times e raised to the power of v, and this is going to be negative v times of 1 positive e raised to the power of v. So this is what I've got. So this is equal to negative e raised to the power of v positive v times e raised to the power of v negative v times e raised to the power of v divided by 1 positive e raised to the power of v. Now I got a positive v times e raised to the power of v, negative v times e raised to the power of v, they both get cancelled, giving me negative e raised to the power of v followed by negative v divided by 1 positive e raised to the power of v on the left hand side, right? So it's y times dv over dy. So now on the left hand side we have got y times dv over dy. Now we will have to make some rearrangements. So if I were to move them, so this is going to be 1 positive e raised to the power of v divided by, if I were to take a negative sign out, this is going to be e raised to the power of v positive v is equal to dy over y, right? Of course there should be a presence of dv there. I place that dv. Now I can integrate them. Now what I would do is, instead of placing the negative sign here, I would like to place the negative sign over here, change it to positive, and then I will integrate these quantities. Now for integrating these quantities, what I wish to do is I will say consider integral of 1 positive e raised to the power of v times dv divided by e raised to the power of v positive v. Now I would like to make a substitution. Let e raised to the power of v positive v be equal to sum t. If I differentiate this, I get e raised to the power of v times dv positive, differential of v is 1. Of course I need to have a dv there. This is equal to dt. So I can always rewrite this as 1 positive e raised to the power of v times dv is equal to dt, right? So this can be rewritten as, this is equal to integral 1 positive e raised to the power of v times dv is dt e raised to the power of v positive v is t, and this is going to give me ln t, but my t is e raised to the power of v positive v, right? Of course we got arbitrary constant c, but we will include it there. So this is going to give me ln of e raised to the power of v positive v is equal to negative, this is going to give me ln of y positive arbitrary constant c. You can always place it there. Now what I can do is I can actually move this to the left hand side, so that would give me ln of e raised to the power of v positive v positive ln y is equal to c. This can be rewritten as ln of y times e raised to the power of v positive v is equal to c. I can rewrite this as y times e raised to the power of v positive v is equal to e raised to the power of c. By properties of logarithm I am able to do this, but my v is, since x is equal to y times v and my v is x over y, I can use this v is equal to x over y over here. So if I were to do that, this can be rewritten as y times e raised to the power of x over y positive x over y is equal to e raised to the power of c. Of course, when y comes inside, this is going to be y times e raised to the power of x over y positive x is equal to e raised to the power of c. Of course, based on your requirement, you can afford to stop here, or you can rewrite this as the following: x positive y into e raised to the power of x over y is equal to capital C dash. So this is a good place to stop for this solution. Students, we are given this question: dy over dx is equal to negative of y times of x positive y divided by x squared. Now foremost, let us perform the homogeneous check. The degree of y is 1, that is taken as a product with x, so its degree is 1. So the cumulative degree of y and x is 2, and then on y is taken with y. As I mentioned to you, the degree of y is 1, this degree is 1, so the cumulative degree is 2. So in all, the degree of the numerator is 2. Now we have to compare it with the degree of the denominator. Clearly the degree of the denominator in this case is 2. So since the degree of the numerator and the degree of the denominator are one and the same, this is a homogeneous equation, and we can make the substitution: let y be equal to v times x. So we will be differentiating this with respect to x. When we do that, we get dy over dx is equal to v positive x times dv over dx. Now what I wish to do is, I would like to take this as 1. So I can rewrite 1 as follows. So 1 can be rewritten as, in place of dy over dx, I would be placing v positive x times dv over dx is equal to, so as a negative sign there, in place of y we substitute vx, x is retained as it is, and then we substitute vx followed by x squared. Now this is equal to, I can take a x out from here, so I would get negative of v times x squared of 1 positive v divided by x squared. So clearly I can cancel the x squared, and that is giving me negative of v of 1 positive v. Now there is v positive x into dv over dx, so this v can be pushed to the right hand side. So if I were to do that, I would get x times dv over dx is equal to negative times 1 is, in fact negative v times 1 would give me negative v followed by negative v squared. This comes, I get a negative v, so I now have negative 2 times v and negative v squared. Now we can do some rearrangement, so I can rewrite dv divided by negative 2 times v negative v squared is equal to dx divided by x. I can take the negative negative sign out, and if I were to do that, this will become positive. In fact, I can take this negative sign and place it over here, and this will become positive. So just rearrangements. Now I can clearly integrate these two things, and we would be able to solve and simplify. So let's get it done. Now to integrate this, I got a dv divided by v squared positive 2 times v. Now this is a perfect square. Say for example, if I were to expand this, say v positive 1 raised to the power of 2, I get a v squared positive 2 times v and positive 1. But I will have to get rid of this 1. So if I were to place a negative sign, in other words negative 1 here, that would be same as v squared positive 2 times v, right? That's exactly what I wish to do. So I would rewrite this quantity as integral dv divided by v positive 1 raised to the power of 2 negative 1, which is equal to integral dx over x. Now negative 1 is same as rewriting it as negative 1 squared, right? And thereby I can use the formula now. Now there is a formula which we can use. Integral dx divided by x squared negative a squared is equal to 1 over 2 times a ln modulus of x minus a divided by x positive a positive arbitrary constant c. So I can use this formula. This is a very important formula. You can remember this and it will come in handy. Now instead of x, I got v positive 1, and for a I got 1. So this entire thing is going to be rewritten as 1 over 2 times of a is 1, and ln of x is v positive 1 negative 1 divided by v positive 1 positive 1, and in this case it's going to be negative ln of x positive arbitrary constant c. Now clearly I can get rid of this positive 1 negative 1, and I can rewrite this as 1 over 2 times ln, I don't have to place a modulus sign, you can just simply rewrite it as v over v positive 2 negative, I can bring the negative sign to this side, so that's going to give me x is equal to c. So this is what I've got. Now what I wish to do is now I've got a 2 here, right? So I will have to get rid of this 2. So just taking that into account, what I will do is, this is actually ln x, this cannot be x, because when negative ln x comes to this side, this has to be ln x. So what I will have to do is I will have to get rid of this 2. So to get rid of this 2, what I will do is I will multiply by 2 both sides. So when I do that, this is going to give me ln v over v positive 2 positive 2 times ln x is equal to 2 times c. So this is what we have got. Now there is a formula which says that if I've got something like this, b times ln a, I can write this as ln of a raised to the power of b. So by this formula, I can rewrite this as ln of v over v positive 2 positive, I can move this 2 over here, writing it as ln of x squared is equal to 2 times c. Now there is another formula which is ln of a positive ln of b is equal to ln of ab. So by this formula, I can rewrite this as ln of x squared times b over v positive 2 is equal to 2 times c. I'm going to use this formula, ln a to the base e, if it is equal to y, then I can write a is equal to e raised to the power of y. So by that formula, this is going to be x squared times v over v positive 2 is equal to e raised to the power of 2 times c. But my y is equal to v times x and my v is y over x. So if I were to substitute that, this is going to give me x squared times y over x divided by y over x positive 2 is equal to e raised to the power of 2c. Now x and x can be cancelled, so that is going to give me x times y. If I were to take the LCM, I get y positive 2 times x divided by x is equal to e raised to the power of 2 times c. Now I can flip it. If I flip it, I get x squared times y divided by y positive 2x is equal to e raised to the power of 2 times c. I can cross multiply. If I cross multiply, I get x squared times y is equal to e raised to the power of 2c times y positive 2x. If you don't want this e raised to the power of 2c, you can write that as x squared times y is equal to some constant times of y positive 2 times x. So this is my final solution to this question, students. Students, we are given this question and we are expected to solve, and we will have to first ascertain if it is a homogeneous equation or not. So for that, what I wish to do is I would like to move my dy over dx to the left and club all other terms on the right hand side. So this is going to be y times sine of y over x negative x divided by x times sine y over x. Now clearly the degree of y is 1, the degree of x is 1, the degree of this y is 1, this x is 1, and comparing it to the denominator, we see the degree of y here is 1, the degree of x is 1, and the degree of this x is 1. So clearly this is a homogeneous equation. So as a first step, what we will do is we will just take, let y be equal to v times x, and then dy over dx is going to be v positive x times dv over dx. So if I were to take this as 2, then I would be substituting this in 2, so therefore I can rewrite 2 as, in place of dy over dx, it's going to be v positive x times dv over dx is equal to, in place of y I will substitute vx, so it's going to be sine of vx over x negative x divided by x times sine of vx over x. So I can cancel the x that I see here, and that subsequently would give me v times x sine v negative x divided by x times sine v. Now I can move this v to the right, and that would give me v times x sine v negative x negative v. Of course I have a denominator as x times sine v. I can rewrite this as v times x sine v. I take the LCM, I would get v times x sine v over x times sine v. Now clearly I have to have one more x here. I think I missed that out, so let me place that x. Now clearly vx sine v and vx sine v can be cancelled, and that would leave me with negative x times x into sine v. Of course on the left hand side I got x times dv over dx. I will move all the x to the one side and v to the other side, so this is going to be sine times v dv is equal to negative x. And probably what I should have done here is, I can clearly see that there is a presence of a x here and a x there. So what I can do is I should have cancelled these two x's, and that would leave me with sine v dv. Of course, that's right. And I can push this dx here, so this is going to be a dx. That's fine. I got a negative sign. I can place that negative sign. I can move the x down. Fair enough, right? So we have to integrate this. So if I were to integrate sine v, I get negative cos v. I integrate this, I get ln of x. Of course, we got a constant positive c there. We have to place that. Now I can rewrite. I know that y is equal to v times x. So therefore v is equal to y over x. So what I can do is I can substitute that term y over x over here, and if I were to do that, I would get negative cos of y over x is equal to negative ln x positive arbitrary constant. See, now what I can do is I can get rid of this negative sign. So if I were to get rid of this negative sign, I need to just multiply by negative, right? So multiply by negative 1 all through. So this is going to be cos of y over x is equal to ln x negative c. Now I can rewrite this negative c as positive of negative c, and then rewrite this entire thing as cos y over x is equal to ln x positive arbitrary constant c prime. That's it. This can be anything. You want to name it as k, you can name it as k. You want to name it as some l, you name it as some l. So the final solution for this question is this. Thank you, students. We'll move on to the next question. Students, we're given this question. We expected to solve x times dy over dx is equal to y positive 2 times the root of y squared negative x squared. Now what I wish to do is I would like to move this x down. So I would have dy over dx is equal to y positive 2 times root of y squared negative x squared divided by x. So this is what I've got. Now you can clearly see the degree of y is 1. Now we got a square root, so that would mean we are talking about the degree of y to be equal to 1, because once you apply the square root, you got a 2. Upon applying the square root, this would be reduced to degree 1. So we got a 1 here, we got a 1 here, we got a 1 here, and we got a 1 here. So clearly this is a homogeneous equation, and so what I would do is I will say let y be equal to v times x, and then I will differentiate this with respect to x. When I do that, I get dy over dx is equal to v positive x times dv over dx. So this is what I've got. Now what I wish to do is I would like to take this as 2, and I will be rewriting 2 using this. So this in turn was going to give me v positive x times dv over dx is equal to, in place of y, I'm going to substitute vx followed by v squared x squared negative x squared divided by x. This is vx positive 2 times. I'm going to take x squared out, so that is going to give me v squared negative 1 divided by x. Once the x squared comes out, this is going to give me x there. So 2 times x root of v squared negative 1 divided by x. I can cancel the x's out. So now continuing on, I can move this v to the other side. So that would give me v positive 2 times the root of v squared negative 1 negative v. I got a positive v and a negative v. They can be cancelled, and that in turn would give me 2 times root of v squared negative 1, and on the left I got a dv over dx. Of course there is an x there. Now rearranging, this is going to be dv over 2 times of root of v squared negative 1 is equal to dx over x. Integrating both sides, I would have something like this. Now for this I would like to use the formula. Now since integral dx over root of x squared negative 1 is equal to, there is a formula, so that is going to be ln of x positive root of x squared negative 1. So we can use this formula. Of course there is an arbitrary constant c. So in place of x I've got v, so this can be rewritten as equal to, in fact I need to use implies because I got a equal to already. So this is going to be 1 over 2 times ln of, in place of x I will have to use v, positive square root of v squared negative 1 is equal to ln of x positive c. So this is what I've got. Now I would multiply by 2 both sides. Now when I do that I would get ln of v positive root of v squared negative 1 is equal to 2 times ln x positive 2 times c. I can move this 2 over here, so this is going to be ln of x squared positive 2 times c. On the left side it's going to be ln of v positive root of v squared negative 1. Now I can move this ln x squared to the left, so this is going to be ln of v positive root of v squared negative 1 negative ln x squared is equal to 2 times c. Now there is a formula which we know, ln of a negative ln b is equal to ln of a over b. So by this is going to be rewritten as ln of v positive root of v squared negative 1 over x squared is equal to 2 times c. There is also another formula which is ln a to the base c if it is equal to y. A is equal to e raised to the power of y. So by this formula I can write v positive root of v squared negative 1 over x squared is equal to e raised to the power of 2 times c, but my y is equal to v times x, so therefore v is equal to y over x. So this is going to be y over x positive root of y squared over x squared negative 1 divided by x squared is equal to e raised to the power of 2c. I'm going to use the space here, so this is going to be y over x positive root of y squared negative x squared divided by x squared is equal to e raised to the power of 2c. Now we can rewrite this as y over x positive root of y squared negative x squared. Root of x squared gives me x divided by x squared is equal to e raised to the power of 2c. Now this can be rewritten as y positive root of y squared negative x squared divided by LCM is x, and I got a x squared here. I can flip it, so this is going to be x cubed. This is going to be e raised to the power of 2 times c. I can cross multiply this and write this as y positive root of y squared negative x squared is equal to e raised to the power of 2 times c times x cubed. I can replace this e raised to the power of 2 times c by means of an arbitrary constant. So I can write this as y positive root of y squared negative x squared is equal to sum c prime times x to the power of 3. So this is my final solution to this question, students.